Hi everyone, thanks for joining me, and yeah, it's a real pleasure to be back at UQ at GP South, which is actually where I did my Bachelor of Information Technology degree. My name's Damian Brady. I am a Cloud Advocate at Microsoft, which means that I usually go and speak to people at conferences, and lately that's all moved online, so this is a bit of a change over the last little while, but it's good to be able to come to places like this and share the kind of knowledge that we have as well. So I work for Microsoft at the moment remotely from home. Before that I worked for a company in Brisbane called Octopus Deploy, and then before that a consultancy in Australia and in Brisbane as well, and a few other places before that. So for about 20 years I've been in software development, mainly as a developer, mainly on the Microsoft .NET stack. But the last 10 or so years, I've been focusing on a bit more process and DevOps and things like that. When I thought about it, it was something that was kind of missing, I thought, from the degree that I did when I was here with Bachelor of Information Technology. And that might have changed a little bit since then. But I do distinctly remember that we barely touched on source control back then. I don't want to date myself, but that was not in the last 10 or 15 years, so things have probably changed. But what I thought I might do, instead of coming back and talking about Microsoft stuff specifically or any kind of tech stack or anything like that, I thought I'd talk a bit more about DevOps itself, the kind of theory behind it and the practice, and what you can expect in organizations around the place, what it actually means, what it's for, and what it's not for, especially as well. So the number one question, first question that everybody asks is, what is DevOps? And there's a lot of confusion around this. You know, the joke is you ask 10 people what DevOps means and you'll get 20 answers, right? A lot of the time these answers are similar, they overlap, sometimes they seem completely different. Most of the time they still tell part of the same story though. It really depends what your background is and what your organization does or what your company does in terms of DevOps, how it's defined specifically. There are a few lessons, and I'll talk about them a little bit later, things that you should not consider as DevOps, and things that you should not do and call them DevOps as well. And we'll look at that a little bit later when we talk about the practical aspects of what DevOps is and what it means as well. Microsoft, though, defines DevOps really specifically. And we do it in a way that's pretty consistent with most tech companies, and most large tech companies as well. But I thought I might play a little video. It's really short, and it's recorded actually by my boss. And my boss's boss was the one who came up with a definition for Microsoft. But I might play that. This is a series called One Dev Question, and this question was put to Abel Wang, who's my boss, to say, you know, what is DevOps?
So what is DevOps? Well, the funny thing about when you say what is DevOps, you ask 10 people what DevOps is, you're probably going to get 20 different answers, right? But at Microsoft, DevOps means something very specific to us. DevOps is the union of people, process, and products to enable the continuous delivery of value to our end users. And now notice I said that really, really carefully, right? And the reason why is because, well, one of them, that definition was created by my manager, so if I get that wrong, right? The other thing is because every word of that was designed very specifically, right? The key is we want to continuously deliver value to our end users, and this is vital in today's world.
Cool. So you might have heard in there the definition that Abel gave as well. Oh, it's playing again. Good stuff. The definition that Abel gave as well, which is that DevOps is a union of people, process, and products to enable continuous delivery of value to our end users. There's a lot of words in there. The most important stuff in there is really these parts. There's the people, process, and products, which you can consider as, it's not just the tools, it's not just, you know, the process of how we deliver an idea all the way through to production. And it's not just the people involved in doing that work. It's all of these things combined. So if somebody comes to you and tells you that DevOps is containerizing your application and putting it on a Kubernetes cluster, that's a tiny part of the story of DevOps, right? Or if they tell you it's the DevOps engineers in the company that take the code, compile it with a pipeline, and then deploy it out to production. Again, that's just a small part of what actually consists of DevOps if you're doing it properly. So there's that whole encapsulated part, the people, process, and products. The next bit is this continuous delivery of value. So I'll focus on the continuous delivery part. The lesson here is not necessarily that every single change that you make to your code should push all the way through to production. It's just that when there is something of value, something that you have changed that you want to give to your customers, that change can be delivered continuously, not put in a pipeline for 6 months until 6 months later they'll get a release that might be what they wanted, right? Ideally, you want to give your customers the features that they want as soon as they're available without kind of being slowed down by some process or something like that. But the most important part of this, which is the bit that I've highlighted, is the word value. So it's not about continuous delivery of code or continuous delivery of infrastructure or scalability or any of that stuff. It's continuous delivery of value. Now, we like to say there's a big difference between working for 6 months on a piece of functionality and then getting it into production and finding out people don't actually want that, or working on something for a week and then putting it into production and finding out that the customers don't want it. In both cases, you've learned that you're not delivering value. You haven't delivered something that's valuable to the customers. But in one case, you've wasted 6 months, and in the other case, you've just wasted a short amount of time. So being able to evaluate what is valuable and continuously deliver that is really important. So before we get into what this actually means day to day when you're writing code, when you're working on projects, I really like to ground all of my talks about DevOps in kind of the literature and the research and the ideas behind DevOps. The number one thing I'd say to do here to learn that stuff is to listen to the experts. So here are 3 people specifically that I like their work. I like their research, I like their books and their literature and so on. Dr. Nicole Forsgren is a researcher in the areas of DevOps and all of the surrounding parts. She now works for GitHub. And so she has produced a number of different bits of literature. She I think co-founded an organization called DORA, or DevOps Research and Assessment, which was acquired by Google, and then she left and went to GitHub. DORA produced a yearly report called the State of DevOps Report, which has a fantastic rundown of the summary of all of the academic research that she did, and with the rest of the team, focusing on all of the important parts of DevOps, what they actually mean for real companies and so on. She also wrote a book called Accelerate, which is really good as well. I'd highly recommend that. But she's kind of the person to look to when it comes to how research actually lines up with the real world when it comes to DevOps. Gene Kim is an author. He was also part of DORA. He is a co-author of the DevOps Handbook. And he also wrote the Phoenix Project and the Unicorn Project, which are 2 really good DevOps specific books. My kind of, I don't know, it's an admission that I don't really read a lot of heavy kind of textbooks. I do that stuff all day, every day. And so when it's time to read a book, I don't really like going through textbook style stuff. So Gene Kim's work is really, really good because the Phoenix Project and the Unicorn Project are novels, and they're written like stories, but they have some really, really important parts to them. And I'll talk about some of them in a sec. I would highly, highly recommend those 2 books as well. Extremely readable and really important. And Jez Humble was a co-author of the DevOps Handbook. Was part of DORA as well. He was a co-author of Accelerate, and he's basically a guy you can listen to when it comes to what DevOps means and how to do it and things like that. So I want to talk about just one piece from each of these people that kind of highlights what DevOps actually is and how you can think about it. So Jez Humble, I'm going to start from Jez and work backwards towards Nicole. Jez has an acronym that he likes called CALMS, and it stands for, I'll give you the words in a sec, but it's an acronym basically for 5 principles of DevOps. They're used to evaluate whether an organization is ready for a DevOps transformation or how well they're doing with their DevOps transformation. And they really highlight these certain areas which, when you hear them, you'll start to think, well, hang on, isn't it about automation and about continuous integration, continuous delivery, you'll notice that it encapsulates a lot more than just those technical aspects. So the C is for culture, which is all about kind of working together, understanding the diversity in teams, the potential of those teams, all that kind of stuff. This lines up with some of the other ideas from the other people I'll mention around psychological safety. And you can think about psychological safety really as the idea that if you think something is going wrong in your organization or in your process, that you feel safe to raise that issue or to suggest maybe we should try and do something a different way. This is in contrast to those organizations where if something goes wrong, they look for a scapegoat. They look for somebody to blame for the problems that occurred. Really popular ideas from this are things like blameless postmortems, where if something goes wrong, everybody gets in a room, you talk about it, nobody gets the blame, nobody gets thrown under the bus, but you discover what the problem was and then you mitigate that problem so it doesn't happen again. So having that kind of culture is really, really important when it comes to actually being innovative and moving forward with your organization. Automation is the next part, and this is where we get into some of the technical stuff. So automated builds, tests, deployments, things like that, continuous integration, continuous delivery. If you have manual processes for a lot of this stuff, it's really not going to move you fast enough. Right? The top performing companies will deploy or can deploy several times per day. Even Microsoft has a product, Azure DevOps, which they spent 10 years moving from a 2-yearly release cycle, so every 2 or 3 years they would release a new version, to every 3 weeks, and they can actually release hot fixes inside an hour through entire organizations. There's 300 development teams, or there are 300 development teams at one point. They'd run 85,000 unit tests for every single commit to a pull request. It was really heavy duty stuff, but they could still push stuff out in an hour because they had this automation in place. Similarly to that, the idea of lean operations. So optimizing the developers and the technical specialists that you have to really make sure that you get the fastest kind of best outcome for your customers. So rather than spinning your wheels doing the same kind of tasks over and over again, spinning up test hardware, for example, or test infrastructure, if that stuff's automated and that stuff is not something that your experts have to think about day to day, you get this kind of flow. This ties in very nicely to Gene Kim's ideas. I'm not actually going to mention them here, but he's got another set of 5 ideals that he talks about that came from the Unicorn project. And one of them is focus, flow, and joy as one of these ideals, which basically means if you're a programmer, the stuff that you should be doing day to day is programming, not talking to the infrastructure team to work out whether you can get a test database so that you can test the changes you've made. Being able to focus on that work is really, really important. So staying lean and making sure people are focusing on their core pieces of work is really important as well. Part of that as well is continuously improving the work you're doing. Our own CEO, Satya Nadella, was quoted as saying, and I'm going to misquote this because I don't remember the exact words, but basically saying if you're ever given a choice between working on a feature or improving the way that you work, so improving the tools that you work with, you should choose that improvement of work every time because that has better flow-on effects further down the line. So improving the way you work, making sure that you're really efficient is really important. Measurement is the next one, which is about making sure that you can actually tell whether what you're delivering is valuable. So we'll talk about experiment-driven development a little bit later, but the idea of if you write a feature and you push that into production and you can't tell whether what you've done is valuable, then you're just going to be guessing. You could be working on that feature and improving it for months and months on end before you finally find out that nobody is actually using that feature. Or you could release a feature that's fantastic, but it's too slow and people don't like it. If you're not measuring these things, you can't make those improvements. We found at Microsoft, one of the recently retired DevOps experts, Sam Guckenheimer, he talked about the rule of thirds whenever you release new functions. So he worked on the Azure DevOps product, And every 3 weeks they would release a bunch of features. And he said it was roughly split into thirds. So a third of those features people really liked and said, that's great, you should invest more in that. A third of them people were like, that's fine, that's okay. And then a third of them people did not like at all. Now, because it was a 3-week cadence, every 3 weeks they'd release these things, they were able to, at the end of that 3 weeks, say, well, this feature that we introduced, people are not going to use that, let's not develop that anymore and pivot towards the stuff that people were actually finding useful. And again, if that took you a 3-year development cycle and you got to the end of that 3 years and found out that people aren't going to use it, then that's a lot of wasted money and a lot of wasted effort. So being able to measure these things and shorten that feedback loop is really important as well. And then the final one is sharing, this kind of open organization where nobody is the holder of information. There's no gatekeeper of information or process. Everybody has that shared goal and that ownership of the products that they're writing actually delivering value to that customer. That's really important as well. So that's Jez Humble's CALMS idea. And you can see there's a kind of high-level goals, principles, and pieces of guidance. Gene Kim has a similar kind of idea, which is the 3 ways of DevOps. So this came from his book, The Phoenix Project. Again, would totally recommend it. It's extremely readable. You can say that you're reading a technical book, but it's just positioned like a novel, so you don't have to feel bored by it. So I really like his 3 ways, and he talks about this as 3 ways of kind of thinking about DevOps. The first way is the idea of systems thinking. So you can think of this as the development from the business point of view through to operating the application or your software from the customer's point of view. And so this systems thinking is about making sure that what you've got, what you're optimizing for is that whole system. So you might want to have your developers upgrade their machines to get their local compile times really, really fast. But then you find, the whole process is slowed way down further down the line. Or you may want to upgrade your build service so you get builds out really quickly, but you have 5 managers who want to sign off on any release anyway. Like that becomes the bottleneck. And if you're not thinking about that whole system, you can optimize for the wrong parts of it. So systems thinking is really about getting the idea from development through to production as quickly as you possibly can. The second way is the reverse. When it's in production, how do you get the feedback of what that's delivered, whether it's delivered value, is it actually working as expected, are there errors, that kind of thing, and being able to amplify those feedback loops. So what I mean by amplify those feedback loops is you don't want quite often when we deploy stuff out to production, we say, well, we're monitoring what's happening there because we've got logs, right? We can just scour the logs and find out what went wrong when something goes wrong. What often happens is if there are exceptions or errors and things that pop up in the logs, you can set alerts so that people get an email to say, hey, this thing failed. And then you'll start to get these exceptions and errors that happen all the time. And so you look at them and you're like, oh, that doesn't really matter. That happens like all the time. It's just going to resolve itself in a few minutes. And you start to desensitize yourself to what those alerts are telling you because most of the time they're not important. You can think about it the same way with tests. If you have unit tests that sometimes fail or integration tests that sometimes fail, you'll start to ignore them and they're worthless then. Like you want tests that will always succeed, always pass. And the reason is you want to amplify these feedback loops. You want to be notified when something is actually wrong and you want to be able to tie that to the actions that you made. So the code that you changed, you want to really easily be able to tell, well, that code I changed led to this problem and I got word of that problem really, really quickly. So making sure those feedback loops are nice and tight. The third way is this culture of continual experimentation and learning. And this comes back to psychological safety a little bit, but the idea is that you want to be able to feel free to try things and try new ways of operating and make sure that that internal loop of we're going to try this thing and see if it works, or try this new feature and see if people like it. If you can really speed up that cycle as people are doing that work, then it means that you can pivot really quickly. It means that you can decide whether something's worth the effort or whether it's not worth the effort as you're going through and introducing things. So that 3 ways that Gene Kim talks about are really high-level ways of thinking about those 3 things. Right. And finally, I want to talk about the State of DevOps report, which is Nicole Forsgren's stuff. And this is a little bit more practical. It's the kind of thing where if you're having trouble getting buy-in from your company about doing DevOps specifically, then this is a good thing to be able to print out and drop on your manager's desk. Or I suppose that doesn't really happen anymore. Email him from your home office to his home office. But this report really kind of summarizes a lot of the research that Nicole and others have done. So the State of DevOps report, because it is part of Dora's publications, and Dora is from Google, part of Google now. That's where you can get it. The 2019 one is the most recent one that I've seen. But it has a lot of research that makes correlations, I guess, between behavior and actual outcomes in the real world. So some of the highlights from it, and this is the slide that we always show managers and people in charge, is that elite performers, that is people who do DevOps really well, organizations that do DevOps really well, they deploy their code, so they deploy changes 208 times more frequently. They have 100 times faster lead time from a commit, so an actual code change, through to that change being in production. But then counterintuitively, even though they're moving really, really fast, they tend to make fewer errors. So when there is an incident, if there is an incident, they can recover 2,500 times faster than low performers from a DevOps standpoint. So people who are not doing DevOps well. But the changes they make are 7 times less frequent. Say, let me start that again. The changes they make fail 7 times less frequently. That's always a really hard one to get my mouth around. So 7 times lower change failure rate. So they're making fewer errors, they're deploying them faster, and even when something does go wrong, they can fix it much faster. There's some awesome other research in this report as well that says across industries, high-performing DevOps teams don't just deliver software faster, they actually help those companies meet their company's own goals faster, which is a weird kind of stretch. If you think about, let's say, an insurance company, and if their goals are to sell more insurance policies, having a high-performing DevOps team will actually help that company achieve that goal. And I'm not just making that up to try and sell something. That's actually reflected in the real research and in the data that Nicole Forsgren and others have gathered. So that can be a really compelling argument for why it's a good idea to do DevOps. Right, so I've talked a lot about theory, and I don't feel so bad about it. I'm in a university, so that seems to be the kind of place to talk about theory. But I am going to talk a little bit more about what this means in the real world now. So DevOps actually in practice. When you go into an organization, when you start working on a project, what stuff can you do to actually improve things from a DevOps standpoint and a DevOps point of view? One thing that I found, especially when people are learning the art of software development and the art of delivering projects, is we tend to focus a lot on what we call the inner loop, which is this idea of you as a developer or an engineer writing some code, running some tests, building it on your local machine, running it, making sure it all works, and that inner loop, that cycle there. This kind of stuff is really important, right? You can be so much more productive with a really good, powerful IDE or text editor if that's your thing, to actually enable you to notice things quicker, run tests really fast. You can have continuous testing and all sorts of stuff that's really, really good with this. But this inner loop means that you can write code a lot better, and it is really important. But if we focus just on that inner loop, you end up with these kind of environments where that inner loop happens. You're doing all of this development, you get a whole lot of work done, and then you're like, now I have a build of an application that works. Let's just put that in production, right? There's a lot of reasons why that's a bad idea, building from your local machine and pushing that out to production, and I'll get into some of those in a little bit. Probably the most obvious one is the idea of a reliance on a single person's machine or a single person's work. Ideally, in a team environment, you want everybody's work to get merged in together, built in a consistent way with consistent infrastructure, and deployed in a consistent way so that you can repeat that process. It happens automatically. You don't get any surprises when somebody commits stuff that clobbers your code. It's a really consistent, streamlined, trustworthy process. So this inner loop is really important, but DevOps is a little bit more about this kind of outer loop. And that inner loop of doing the development and making sure that that's really efficient is really just this small part of this whole cycle of software delivery or technology delivery, right? Writing the code, yes, important and arguably the most important part, but unless you're delivering it in a consistent way, you're basically just spinning your wheels. We might have heard the expression, it works on my machine, or the one I like is, if it's not in production, it doesn't count. And you also hear these things about the bus factor. Maybe I'm dating myself here, but the bus factor was a big thing when I was at university, which is how many people in your team need to get hit by a bus before the project is unretrievable, right? Is all the knowledge stored in that one person or on that one person's machine or in this one location, right? By having a really effective outer loop, great source control, great automation and all that kind of stuff, you mitigate those problems a little bit. All right, so in practice, there's a lot of different ways we can split this. The way I'm going to split it is these general ideas of the kind of processes that might be involved in a project for an engineer or for somebody involved in actually producing that software. So before I go into these, I'll give you a chance to glance at them to see what's involved. I'm just going to have a sip of water so I can keep talking for a bit. All right. So we're going to start going around this circle, but we'll jump into this infrastructure, which kind of underlies the whole thing in a little bit. What I'm really going to be giving you here is kind of a selection of tips that I've learned at a number of different companies, both ones that I worked for directly, ones that I have consulted for, some learnings from some super smart people at Microsoft and outside Microsoft as well. Just some things to think about when you're on these projects. So let's think about planning. Hopefully in your degrees and in your work, you've been looking at the ideas behind Agile and things like that. Hopefully lowercase Agile, so Agile software development rather than Agile that's sold to you by a company with a capital A. Agile is really about being able to react to changes and plan your work in a way that's able to be, you can respond to things that actually happen rather than this big upfront planning, trying to do some work and then hope that it's still what people want. The key here though is really to invest the effort when you actually need to invest the effort. So there's nothing wrong with doing this upfront planning, so thinking about all of the different parts of your application that you want to implement, but there's definitely no real point going into huge minute detail about how you're going to implement a specific feature if you're not actually going to implement that feature for another 6 months or another 2 months. Make sure you are across what needs to happen at a high level, but don't really drill into the details until just before you're going to do it. The reason is the world might change, and we've seen that already, right? Stuff that was really important a week ago may not be really important now. So if you've just spent a huge amount of time and effort planning something out and find that that's actually not what you need to deliver, then you've wasted that time. So yes, have a good idea of what you want to do, but don't really invest the effort in the intricacies of the design until you actually get to that work. What this means is to groom that backlog effectively. So this is kind of agile terminology, but you can think about the backlog of your work as all the different items that you need to do. Whether that's just a list in a spreadsheet, or I can see behind some of the people here, there's a lot of post-its on a whiteboard. That still happens everywhere. So that is your backlog. Grooming your backlog is basically looking at what's on that backlog, reprioritizing it, and maybe even taking things off, adding things on. So to be able to invest the effort when you need it, it means you need to be able to groom that backlog regularly to find out what's important and what's not important. Importantly here is to remove these stale items. So I've worked in a number of companies where you have something that's really, really important, right? It gets put up there initially as like a really high priority task that you need to complete, a feature you need to do. And then that first sprint planning session comes along and they say, oh, it's not actually that important, let's just move it out. Maybe we'll look at it in the next sprint. And over time you realize that this same task has been moved out of each sprint over and over and over again. Something that was really important is now suddenly you haven't touched it for 6 months and you're not really sure why it's there anymore, but you're sure you'll get to it at some point. Killing those items or removing those items from your backlog is super important. If they're actually important tasks, they'll come up again. But having a backlog that's not 700 items of things that you would like to do is really important for being able to actually groom effectively. So remove those stale work items. One other part of planning as well is not to assume that the work that you've got on your backlog is work that is actually going to deliver value to people. We talk about this as hypothesis-driven development, which is a really scary thing, especially for project managers. The idea that the work you're doing now is not necessarily going to deliver the outcome that they want is a very scary concept in management. If you can accept that, or if you can get your company as a whole to accept that everything that you push out to your customers is an attempt at trying to provide value for them, and maybe it won't work, then you can be a lot more responsive to things that actually occur, to changes that happen in the environment, and all of that kind of stuff. You remember that rule of thirds that I was talking about? A third of the stuff you produce, people aren't going to like. So you need to be able to accept that everything you produce is a hypothesis. You think this is going to provide value, but maybe it won't. And we'll talk about that a little bit more when I get to monitoring what's happening in production. You need to be able to tell whether it's providing value, otherwise you're just guessing at the result of your hypothesis. So in terms of planning, here are my kind of key points. Invest the effort only when you need it. Groom your backlog regularly. Remove stuff that's old. If it's really important, it'll come up again. And accept that everything you're delivering is an experiment. It's a hypothesis that you have that something you're going to do is going to deliver value. So that's the planning part. We're going to talk about writing code in a sec. So one of the aspects of writing code, especially when you talk about DevOps, is this idea of continuous integration. So this is where your build server will integrate all of your code with the code that somebody else has written, make sure it all builds and compiles, gives you a good artifact that you can deploy, and so on. What we often see in the real world is what we call continuous isolation. So if you think about branching strategies, especially in a version control system like Git, which is kind of the one that seems to have won the war here, a pull request and a branching strategy is really common in Git, regardless of what you call it. So the idea is you have this main branch, or your trunk branch, which is should be the working application at any one time. And then you branch off that, do some work, and then you try to merge back into your main branch. The danger is if that branch is a long-running branch. So you do a branch, and then 2 months later you haven't merged back into your main branch or your trunk. What you're working against is different than what your main branch, what the reality looks like right now. So what you want is these short-lived feature branches. Now, the reason I say that that's continuous isolation rather than integration is you're not actually integrating your code with everybody else's code. If you have a long-running branch, your code is sitting in this isolated little bubble, and you get, when we try to merge again, you get this, what we've called a merge bomb. In other words, I've changed 400 files, so has that person, and somehow we have to get these to work again. Right? The key here is really to make sure that you have these short-lived branches and merge back into that main branch really regularly. I also said, though, that that main branch should be your working version of your application. So how do you manage that? Like if you want to do a big piece of work and merge that work back into your main branch, but don't break it at the same time, how can you manage that? This is probably the most controversial tip I'll give you. A lot of people hate this, is to write dead code. So write code that never gets called in production. I'll explain what that actually means. So let's say you have a piece of code that does a whole bunch of work. Let's say you're using a library to do some tax calculations, for example, and you decide you need to replace this part of that code, right? What's typical is that people will branch from that main branch and they'll work on that piece of code. They'll change the code that's in that file and they'll change unit tests, they'll create new unit tests. Maybe this is symbolic and there's 300 files involved in this change, right? The idea is you're overwriting those changes. What that means is when something's half done, when you have half made that change, you have three choices. You can either wait until you're finished, in which case you get this long-running branch and then a merge bomb when you try to actually get that back into your main branch. So don't commit and don't push back to your, don't merge back to your main branch. Or you do commit and everything breaks and everybody else has to wait until you've finished your work before it actually continues. Or you make sure it doesn't actually fail your compilation, but stuff is not actually going to work very well, so you can't quite deploy it until you've finished your work. So all of these are bad scenarios, right? You're stopping everybody else from delivering these features. And remember, the idea behind DevOps is to enable continuous delivery of value. If somebody else has a new feature that's ready to go and you're blocking it because you've broken the build, that's a really bad scenario. They're waiting on you. You're not delivering value. So instead of doing this, instead of just writing this and having this blocking situation, what you can use are techniques like dependency injection, inversion of control, either feature flags and things like that, to extract and isolate that code away from the rest of the code. Basically put an interface over the top or an abstraction layer over the top, and then tell your existing code to call that new one. Now, functionally, nothing's really changed. You've still got that same code being used from the part that it was being used before. It's just that now it's isolated. If you have this inversion of control dependency injection scenario, that means that you can deploy everything while you're working on this replacement bit of code. So that example, the tax calculations, let's say you now need to expand it to 3 or 4 countries. Your first change could be on a short-lived branch that puts an abstraction layer over that defines a number of functions like calculate tax. Maybe you add one more argument in there for the country, but that's always going to be Australia until you actually finish the new work. You set up in your configuration that will always resolve to this instance of that or this implementation of that tax calculation library that you've got. Meanwhile, you work on another piece of code, which is a new implementation of that. The best thing about this as well is if you think you have something that's going to work, you can, in production if you want, switch to that new working code or that new potentially working code. And if it doesn't work, just switch back again and go back to the drawing board. The benefit of this is that you're deploying stuff that's not quite ready yet, but you're not blocking anybody else. You have a short-lived feature branch, which is just to extract that and abstract that away, that code away, and you can continually push your changes into your main branch, deploy out to production, and do it safely. So you're not blocking anybody else, but you're also not running broken code. Again, controversial. Some people don't like the idea of code that doesn't work in production, even if you're not going to call it. I think the trade-off is well worth it. So there you go. That was a lot of talking because that's one of my favorite subjects, that one. One of the other things you can talk about is the idea of pull requests and pull request builds. So the idea of shift left is a really key concept in DevOps. In the real world, it's much cheaper to fix a problem the earlier it is in your life cycle. If you can notice a bug in your IDE while you're writing that code, that is a lot cheaper to fix than if you notice it on your build server. Or ideally, you don't want this, but if you notice it in production, that can be very expensive to fix. So DevOps is partly about shifting left, shifting the discovery and fixing of bugs and things like that as far left in that life cycle as you can. Having a pull request process where nothing goes back into your main branch until it actually passes some builds and some tests is a really good way of doing that as well. There's plenty of literature out there on how to do pull requests and do them really well. All right, so those are the key ones here. Integration, not isolation. So make sure you're actually merging your code back with everybody else's code regularly. Having short-lived feature branches, so none of this long-lived branches just to do big pieces of work. Try to make them as short as possible. Don't be afraid to write dead code. Write code that is not going to run in production. It's fine as long as you're sure it's not going to run in production. And it will unblock everybody else while you're still working on it. And then pull request as well is an important process these days. Right, we haven't got too far through this. The others will be faster, trust me. When I got to writing code, I'm like, oh, here are all these things that I care about. Let's talk about tests. That should say tests, not infrastructure. Oh no, that isn't infrastructure. We're going to skip away from tests. We're going to look at the infrastructure first. The idea of having infrastructure as code and things like that, which basically means all of the definition of the infrastructure, the virtual machines or the services that your application runs on, they're all defined in code. Rather than somebody clicking through a UI, whether it's Azure or AWS or GCP or even on your local machines. The idea of defining what's required by your application in code means that it's easy to spin things up to test them. So the idea of containerization, so Docker and things like that, really was driven out of this idea of being able to avoid these avoidable problems. So everybody who's delivered a project has been in a situation where it works fine on my machine, but when we deploy it to production, it doesn't actually work anymore because there's something different in production than there is in my local machine. If you can define the requirements for running it in production in code, that means you can spin that up and test it ahead of time. Containers are really good for this too, because the container running on your local machine can be the same container that runs in production. There might be some small networking changes, DNS changes and things like that, but ideally you're running exactly the same stuff. So infrastructure as code, whenever you see that, is really about making sure you can define what your application needs to run before you're actually trying to run it in production. It also means that you can rebuild your infrastructure or patch your infrastructure and verify that that will still work with your application. If that deployment of your application also involves deployment of your infrastructure, that means you can test it in its entirety before you're trying to put it in production. This can be really good for testing things before they get to production, but it can be really good for testing ideas that you have just locally as well. If you have everything defined in your repository and you can just say, I just want a test environment to test the changes I just made, everything can get spun up in the cloud in a small kind of sandbox, run all your tests, make sure that all works, and then just tear it down at the end. That can be really, really effective for being able to verify that changes to infrastructure and code all work together. The idea is these reproducible environments. Things that you can say, well, we know that that application and the infrastructure is going to work in production because we did exactly the same thing in a non-production environment and it all went fine. The key lesson here, though, is that infrastructure is kind of part of your software. It's very easy as a programmer to think, I just write the code and then I compile it and it gets put on a server somewhere and then it runs. But the reality is that server needs to have the same dependencies and the same resources that your software expects, otherwise it's not going to work. These things don't live in isolation, so it's important to be able to account for infrastructure when you're delivering your software. So being able to put infrastructure in your source control, define it in code is really important as well. All right, let's think about testing. I think the best way to think about bugs is as technical debt. If you have bugs, you have lowered quality, and these are things that you're going to have to come and fix later on. So paying down technical debt as early as you can is really, really important because debt builds on itself. If you have bugs now that you don't care about right now, they're going to exacerbate bugs in the future. But it can be overwhelming sometimes to try and fix all of the bugs that you can see. The lesson I'd give you there is that better is better than perfect. So rather than trying to sit down and remove all of the bugs and then release perfect software, If you're aware of these bugs and you're trying to pay that debt down as quickly as you can while still kind of maintaining momentum, making sure that every time you touch a piece of code, it's better than when you got to it, that can be really important as well. Tests are often these things where we try to get code coverage of, 90, 100% of our code is tested by unit tests. I'm not a huge fan of that. I think it's very easy to game that system. If you're judged on how much code coverage your tests have, it's very easy to write a test that just exercises a whole bunch of code and then does an assertion at the end to say, hey, did this function get called? Great, excellent. Tests passed, right? But you're not actually testing what that function does. And if that's your main aim, getting 100% code coverage, you're not really testing the same things. I like the idea of red-green refactor as a way of doing better software. The general idea is if you find a bug, or if a bug is raised, you identify that there's a bug, rather than just going and fixing that bug, if you can write a test that shows the existence of that bug, then fix the bug, make sure that test passes, and then do any changes you need to do with your application, knowing that at that point, if you reintroduce that bug, you have a test that'll catch it. That can be a really powerful way of improving things as you go. So the idea is you write a test, it goes red or fails because the bug exists. You fix the bug, the test goes green because that test already exists. And in the future, when you refactor, do any other changes, ideally that test is green. So being able to identify those bugs is really important, especially for regressions and bugs that crop up later on. The other thing, and I think I mentioned this a little bit earlier, is that in terms of tests, every test should pass every single time. If you have tests that don't pass sometimes, but that's okay, then they're worse than no tests at all, right? Because it's very easy to think, well, this test fails sometimes, it's fine. There's an organization, I'm not going to narrow it down too much. It's in Australia. I know some people who worked on some software there, and there was a particular day of the week where their tests would fail, certain tests would fail. And the reason they failed is because on that day of the week, the prices for some of their things changed. And that meant that their tests now were expecting the normal price, but they were the discounted price. So the tests failed on that day of the week. That was all fine. They thought, oh great, no worries. We're running those tests on this day. We don't have to worry about it if they fail, which is a terrible scenario, right? You want to know if there's actually a bug on that day of the week. It's not good enough to say, well, 6 days a week, we can tell whether we introduced a problem, right? So every test needs to pass every single time. I mentioned the Azure DevOps product that has 86 or so thousand tests that run on every single pull request. Every single one of those tests must pass before any code can get merged back into that main branch. That's super important. If it doesn't pass, it cannot get merged back into the main branch. All right, so testing. Bugs are technical debt, so you try and pay them down. They get worse over time if you don't. Try to make things better as you adjust your code. Don't try to write tests to cover absolutely everything. Just try to improve the system as you go. Red-green refactor is a great way of doing that. And make sure that your tests actually pass every time. And if they don't pass, that should indicate an actual bug. Right? If they fail and you think that's okay, it's not. Right? The test should be there to show you when something's actually wrong. Building and versioning is kind of a thing that I care about a lot. Quite often when you have a piece of software that you make some changes to and you build it, and then you release it as version 1, and then you realize there needs to be another change, so you build it again, and that's still version 1 because you didn't really change much. That can be a bit of an anti-pattern. It's a difficult thing to trace what changes were made and what changes exist in that version. The idea, or ideally, you should have the ability to build your application once, have a specific version tied to that application, and then be able to deploy that same thing through your test environments through to production. So that same single versioned artifact, the thing that you have produced as part of that build, is the thing that goes through your environments. That way you can actually look at what is being deployed and say, well, that contains these changes, right? It's not, I think it contains these changes because I recompiled at one point. Right? So you can build it once, you can pass that through your environments. Being able to identify what you're passing through is really important. It might work really well to build it on your local machine, on your dev machine, but in the spirit of DevOps and working as a team, only the stuff that builds on the server matters. Right? The integrated stuff, continuously integrated work, that's the stuff that matters, not the stuff that was built on your machine. And again, every single artifact, every single build that you do should be specifically identifiable. And the reason is provenance is key. You want to know what is in that build so that if something goes wrong, that feedback loop that we were talking about with Gene Kim, you can identify this change was made, produced this build, so it must be that change that was the cause of the bug that we're now seeing that wasn't in the previous one. If you can't identify that build specifically with a change that was specifically made, then it's very difficult to identify what the problem actually is. So those are the builds. Building and versioning is really important. It kind of ties in a lot to deploying to production as well. This is my number one, probably number two controversial opinion. Your production environment is a test environment. Right? It's not very comfortable for people. People say, no, we have a test environment, or we have a QA environment. No, production is also your test environment, because it doesn't matter how much you try to get your pre-production environments just like production, it doesn't have the same users on it. It doesn't have the same traffic, it doesn't have the same data, it doesn't have any of the stuff that makes it really production. So if you think about production as a test environment and everything pre-production as a simulation of that test environment, that can go a long way to changing your mindset about what you're actually delivering. This is in line with the experiment-driven development or hypothesis-driven development. You think that this is going to work, but it's not until it actually hits production that you can really test that hypothesis. So production is a test environment. It's sometimes going to go wrong, so you really need to make friends with failure. So expect that something will go on and have processes in place that help you mitigate and fix those problems when they do go wrong. It's traditional in software development to try and do as much upfront planning and testing as possible so that nothing can possibly go wrong when you actually go to production. But that's just a fallacy. Something can go wrong. The more effort you spend on preventing problems, the less effort you're spending on being able to respond to problems. So it's important that you acknowledge that something can go wrong in production and you need to be able to handle it when it does. One way of doing that is deploying less with each change. If you deploy smaller changes more frequently, then you're deploying less risk each time. If you save these changes up for 6 months, deploy everything in one big hit, then you're introducing a lot of risk at once. If you're deploying small changes multiple times a day, then you're deploying less. There's less risk every time you do it, which is really important. And as long as your feedback loop is effective, you can identify when something actually goes wrong and be able to tie that back to the change you made. One of the other things that a container is really good for as well is bringing this production environment back to the developers. Traditionally as well with software development, actually deploying to production was this thing that you get to at the end of the project. So you'll work for 12 months to develop this software, and then when you're finished, now we need to work out how to put it in production. If you can put that production environment in the hands of developers immediately, or even build a pipeline such that as soon as you make any change, it will go through to production until right at the start of the project, then production isn't this far away thing we don't have to worry about yet. It's much, much easier to deliver things in small pieces. One of the other things I kind of touched on when we were talking about writing dead code is separating the deploy from the release. So if you have a change that you push out to production and using feature flags and things like that, you're able to use the old code or change some configuration and point at your new code. It means that you can deploy these changes, make sure you're really ready for them to run in production, and then the actual release of this feature can become a marketing event or a business event. We're going to light up this feature right now, and they just flick the switch and the code's already in production. It's ready to go. that can be really handy for being able to test that things are right in production, so it's not a surprise when you try to do it. And also be able to control the release of these new features. Again, feature flags is a great way of doing that. Probably a bit too much information in feature flags to talk about now. There's plenty of talks and other stuff out there about feature flags. So a lot of things I hit then. There's one more part, which is this gathering feedback. The number one thing here really is just focusing on the customer value. And this goes back to that definition right at the start. Value is the thing that matters. There's a really good t-shirt, a really good saying as well by Charity Majors, who runs a company called Honeycomb, who's big into observability and monitoring, which is nines don't matter if users aren't happy. So we all hear about these 5 nines of availability. If you have 5 nines of availability of a terrible product, it doesn't matter how available that product is. You're not gonna make people happy. So being able to focus on the customer value is really important. And again, hypothesis-driven development is a really effective way of doing that. Ultimately, the work you do should be only complete or only done when you've decided and when you've identified that it's valuable. Or it's not valuable, but you learn something and you can pivot and move towards something that is valuable. Again, if you don't measure what's actually valuable in the real world in production, then you can't know whether it's valuable. You're just guessing that the work you did is actually providing value. So make sure you have mechanisms in place to make sure that people can evaluate whether it's actually giving them a good result or not. So you got gathering feedback. Customer focus is the number one. Is this thing that we're doing actually providing value, and can we even tell if it's providing value? So these are kind of the broad ideas behind actual software projects and what DevOps can mean in practice in each of these areas. And again, part of it is thinking about the difference between this inner loop and the outer loop. Yes, it's very important to have an effective inner loop, but unless you're talking about that whole system of delivering software that's valuable to customers, you're missing a lot of what DevOps is about. When you're actually going to implement these things and do these practices, it's really important to drop back to the theory. The theory is your baseline. I've added one more name to this, which is my boss's boss. He's kind of the DevOps guy at Microsoft, Donovan Brown. He came up with that DevOps definition that we use. So these 4 people are really good people to look for when it comes to real world DevOps and how to actually do this stuff. There's a lot more resources around DevOps. As you might have guessed, I talk about this stuff a lot and I can drill into a lot of those topics. There's a URL there that you can go to. It's just a GitHub gist with a whole bunch of links. I add to it all the time. So that's kind of a good starting point for the stuff pointing out to other resources. You can also, if you have any questions later on down the track, you can reach out to me as well. I'm most active on Twitter, DamoVisa. But you can also, there's a blog that I don't update anywhere near enough. I am working on a 11-part MLOps series, which will be starting pretty soon. So DevOps for machine learning, which is a kind of a cool topic. And you can get hold of me, DamoVisa at Microsoft as well. So yes, thank you so much for having me back here. It's been really good. I have some of the questions just here, and I don't think there are very many. I think it's, there's somebody asking whether we can drop the link in Slack, which I imagine one of the organizers will definitely do. Cool. Awesome.
Okay, cool. Thank you, Damian, for giving this talk. It was a pleasure to have. Oh, sorry. Thank you, Damian, for giving this talk. It was a pleasure to have you. As is tradition, here's a UQCS mug.
Awesome. Thank you.
Yeah. So on Thursday we're going to be having something. Oh, sorry, we're going to be having finance for computer science with James Copperthwaite, and next week we'll also have a bunch of cool events. Yeah, thank you for getting this talk.
Yeah, of course, no problem. And yeah, feel free to get in touch. Yeah, thanks.
Okay, cool.